Okay, I think it is 1 o'clock. And the presentation on the main stage is done. Can you all hear me, or at least confirm me that you can hear me?
Yes.
Good.
Yes.
So welcome everybody to the data-driven design session, one of the first session in the main program of the design conference. It's very exciting to have you all here for the first time design online. Also a big challenge for the organizing team, but let's hope that everything will go okay. So in this session we have 5 very good papers and nice presentations. As you may know, the presentations were actually recorded prior to the conference, and we will play all of them now. After this is done, we will open the discussion. So I would like to ask everybody to mute their mics during the presentations, and also I would like to ask audience to be free to use chat during the presentations to post the questions. Oh, I see that also Jin Yang join us. Welcome, our 5th speaker. So we are all here. So we have 5 papers. The first one will be presented by Alessandro Bertoni from the Blekinge Institute of Technology in Sweden. So he is associate professor there in mechanical engineering. Then he will talk about data-driven design in conceptual development. The second presenter will be Kristoffer Vandrup Sigsgaard from the D2. He is the PhD candidate at D2 in the group of the Niels, Henrik, and Mortensen, and he will talk about structuring and contextualizing historical data for decision making. The third presentation will be given by the Jihan from the University of Liverpool about the data-driven approach for creative concept. So Jihan is assistant professor in the School of Engineering there. Then we will have Jin Yang Tan from the Imperial College London, who will talk about identifying critical data during product customization. He is also a PhD candidate in design engineering from the Dyson School at the Imperial College. And our last presenter today will be Sri Kumar Aydua from the Blekinge Institute of Technology, from the group of Tobias Larsson, and he will talk about data analysis method supporting cause and effect studies in product service system development. I hope that we are all set and ready, and I will ask our helper actually to start with the presentations. Please enjoy, use the chat to discuss and post the questions, and looking forward to hear from all of you after the presentations. Thank you.
Hello, everyone. Welcome to my presentation titled Data-Driven Design in Concept Development, Systematic Review and Missed Opportunities. My name is Alessandro Bertoni. I am Associate Professor at the Department of Mechanical Engineering at Blekinge Institute of Technology in Sweden. The paper I'm presenting today is a systematic review with the goal of answering the question how data-driven design methods are currently used in concept development, and what are the major data sources and data science algorithms that are applied in such a context. I've done this through a systematic review using the keywords that you see on the slide here, limiting the subject area to engineering. And I also want to remark that what you're going to find in the paper are all the papers that were available in Scopus up to August 2019, where the paper search was run. This is a snapshot of the overall paper identified, 127, focusing on the whole product development process, of which 52 concerned concept development, the orange area that you see in the slide. And as you can see, most of the publication comes from the last 5 to 6 years. What and how data-driven design has been applied in concept development? Those are the main subphases where data-driven design methods have been presented. Mainly, in identifying customer needs. The large majority of the paper that identified worked on the identification of customer needs. Smaller amount on establishing target specification, some other in design space exploration, and so. This brought me to split the analysis in two. So what are the data sets and algorithms that were used for the identification of customer needs? And what are the data set and algorithms that were used in the other sub-phases of concept development? In the upper picture, you see data related to identification of customer needs. The central diagram shows the data sets. Where do the data came from? Those were mainly online reviews, social media, textual customer reviews. And on the right-hand side, you can see what are the algorithms that have been used to analyze such data. And in this case, text mining is by far the most applied methodology for analyzing these data. If you look at the other sub-phases of concept development, you see in the central diagram concept description, early simulation datasets, and pattern database to be the first three more used datasets. And on the right-hand side, not really a major methodology or algorithm that has been applied for doing data-driven design. What is this telling us? Well, if you take the data-driven design definition from Kim et al. And others, this has been defined as an opportunity granted by the increased diffusion of cyber-physical systems. And there's a slight contrast by the fact that there is a predominance of text mining techniques from data from social media online reviews, which does not really show the link between actually the capability to use cyber-physical systems to collect such data. Of course, it is easier, it is cheaper to collect data from social media, online reviews, but this has the drawback that might actually not be able to elicit those tacit needs since the data set has already been elaborated by the customers itself. Another point of discussion is about the necessity to actually proactively plan and design a system to allow data-driven design implementation, especially for cyber-physical systems with communicating assets. And there is a need to make evident that there is a value cost trade-off and what is the benefit of actually implementing the data-driven design approach. In conclusion, for engineering practice, there's a need to have a more structured approach for proactively plan for implementation of data-driven design. Again, making clear the trade-off between cost and value. And from a product development theory, there's a need for a clearer definition of what shall be considered a data-driven design approach. What is the discriminant telling us that a data-driven design approach is as such? Is it the nature or the origin of the data set? Is it what kind of algorithm, data science algorithm, or traditional statistic is applied? That's an open question that can be discussed. Thank you for listening. I'm open for questions.
Hi, today I would like to talk about my paper, Structuring and Contextualizing Historical Data for Decision-Making in Early Development. My name is Kristoffer. I'm a PhD candidate doing my third year at the Technical University of Denmark. My main research area is what we call modular maintenance. And today I would like to talk about why do we need data in early development, the method we present of structuring and contextualizing the data so it's easy to use in early development, and then through case 1 and case 2 I will discuss the result and come with my final conclusion. So why do we need data in early development? In early development, you're taking a lot of the critical decisions. So a lot of decisions have a big impact and are really defined early on. So for example, the impact could be cost, it could be environmental impact and stuff like that. We're really taking a lot of those decisions early on, and they are very hard to change when we come later. We also know that in the beginning, when we design a product, there's a lack of information, there's a lot of uncertainty, and we would like more information to be able to take the right decisions. And we also know that the more we need the knowledge we have already created in our company, the more intelligent we can actually act. So there's really a high need for using data, but of course it can be difficult because the data might not be available and it might be hard to use. So with our methods, we think we can structure and contextualize the data and thereby make it more usable in the early stages. So how would we do that? First of all, we would like to deconstruct the product. So if we, for example, see here is an example of a bike. We have the product, that's the bike itself. We have the system, that could be the frame, the drivetrain, and the wheel. And then we have the component. So for the frame, that could be the main frame and the wing and the front fork. So the whole key is here that we need to deconstruct our product, or decompose our product. And then we have this, we can actually start contextualize it. So when I have my bike, I, for example, here have bike 1, I know that's using frame 1. And if you look at bike 2, I know this is using frame 2. And then we can link all the data to this. For here, I have 2 data examples. The first one is the cost. So here I know all my components and what they cost. And then I have customer complaints. So how many of my sold frames have a customer complaint? And then the key here is how we link the data. So we always suggest that the lower you can link it, the better. I will come a bit more into that. But if we look here, we have linked the data to the component level. So that means that I can see the cost on the bike level, or the product level, and also the system level and the components level. And to really understand this, we can take a comparison between 2 bikes here. Down here, you can see the data we have available. And if we want to see the price between bike 1 and bike 2, we can go in and just add all the prices for the components, and thereby we will have the comparison. We can do the same if we just want to look at across the bikes, but at the different frames, how are they performing? And again, we can do this down to even lower level for the components. And this means that by contextualizing and structure our data, it's very fast for us to maneuver around in the data and actually see, okay, what does the impact of changing a components and all that stuff when we are building a new bike. So it is really helpful. That's also what we could see in our 2 cases. But you can say, we always say that we should link our data at the lowest level possible, but that's not always possible. So if we look at our case 2 here, it was not possible to link the data on a very low level. Actually, it was at the product level. So we could only compare between the different products we have already built. But still, it gave a huge help to take better decisions because we could see which product that have went really bad and which one that went really well. And thereby, we could actually take better decisions and be informed by the data we already had. In our case, too, it was a different story because here we could link the data to the component level. And thereby, we were much more flexible in how we could analyze and use the data. So that means that by structuring and contextualizing the data, we can really take better decisions and we can really use the data. So thank you a lot for your attention.
Good afternoon, everyone. This is Jihan from the University of Liverpool. And today, I'm going to talk about a data-driven approach for creative concept generation and evaluation. Conceptual design, as an early phase of design process, has a high impact on determining the innovation level of design results. Studies reveal that during design process, 60% of design engineers' time is used to explore the needed information and knowledge, especially when implementing emerging technologies. So, in this study, we would like to propose a data-driven approach to solve this issue, to support designers in implementing emerging technologies into new products. And we have 2 parts in this exploration. The first part is focused on concept generation method. The second part is focused on the evaluation method. However, our core idea of the data-driven approach is that concept generated in the conceptual design stage should be capable to be evaluated easily. And the evaluation process should be integrated within the concept generation process. In order to help designers understand emerging technologies, we need to provide designers with a knowledge database containing how people perceive new technologies. There are several existing databases like that, such as the B-Link and TechNet. So here's an example produced by B-Link on a new emerging technology, augmented reality, which shows the people's perception of augmented reality. And then combinational creativity is one of the easiest approach for people to produce new ideas. And there's a tool called a Combinator. It can generate combinational stimuli in text and image forms through combining unrelated ideas. Okay, so for example, here we want to produce a combinational idea about a navigation application. And the stimuli here created are navigation history and navigation running. So if you want to implement augmented reality into this navigation application, then we need to use the B-Link to produce the database or the knowledge base about augmented reality, as well as use a combination of stimuli. Okay, we use them together, we can come up with the augmented reality history navigation app and the augmented reality running navigation app. And then we need to evaluate the ideas generated. Distances plays an important role here. So the majority of studies suggest that far-related ideas could inspire more creative design outcomes. And there are several tools that can evaluate the distance between ideas, such as ConceptNet and TechNet. The lower the value indicates the further the distance. So for example, here, the concept shows that navigation running has a low distance value. So it indicates that navigation running has a higher potential to be converted into a creative concept. So based on the previous explorations, we came up with a data-driven approach. So first, we provide designers with a knowledge base, okay, to help designers understand the emerging technologies. And then we use a combinational-based computational tool to produce combinational ideas or inspirational stimuli. And in the same time, the ideas produced by the combinational tool are evaluated computationally by using idea distances. And the evaluated ideas or the selected ideas are then produced in text and image forms and delivered to the designer together with the knowledge base. So by using those two, the knowledge base and the selected combinational stimuli, the designers can come up with design concepts that incorporates emerging technologies. Okay, so here's an example showing how the data-driven approach is used. It's basically based on the previous explorations. In conclusion, the new approach could support the creation of more efficient and capable products. However, this research indicates that in future computational design tools, we should not focus only on generation or evaluation. We should focus on both of the activities. And that's all. Thank you.
Hi guys, my name is Xingyang Tan. I'm a PhD candidate from the Dyson School for Design Engineering, Imperial College London. The topic of the study is to identify critical data during product customization, a case study of orthosis fabrication. Product customization as a manufacturing strategy fulfills specific customer needs, requires data collection from the end users or the manufacturing process. Data can be collected with various methods, for instance, from the embedded sensors, customer orders, survey, or feedback from the product usage, etc. However, it is a challenge to narrow down and identify the most valuable data that affects the customization process. Thus, targeting the right place and time to collect less but only essential data is critical. This study proposes a 7-step method using variable product analysis to extract the related data from the customization process. First, potentially related data from end users are collected, for example, the required sizes, functions, age and gender, etc. Second, the data from the manufacturer or fabricator are acquired, such as the working experience. Third, the verbal data can be gathered using the think aloud technique during the customization process, and the verbal data is converted into text and segmented to build a coding scheme. Then the time spent and iterations of major activities are calculated to derive main features that represents the customization process. Finally, qualitative and quantitative analysis are conducted based on data collected from the 3 sources and to review if data of end users and manufacturers affects the customization process. A case study is demonstrated in this paper about clinical customization of hand and wrist orthosis. It is a common treatment to prescribe customized orthotics for patients with hand injuries, neuromuscular or musculoskeletal diseases. Low patient compliance has been found due to discomfort and pressure sores. A more efficient customization is in need to fit orthotics right first time. However, as orthotics fabrication is highly dependent on experience of therapists, and the fabrication process involves various tasks and can be affected by so many factors, thus we applied the proposed method in this case. 3 examples of related data were evaluated: the number of joints to be stabilized, the working experience of therapists, and the in-outpatient department where the patient comes from. 4 therapists and 18 patients were recruited in this study. The full process of customization was filmed by a camera. All therapists were asked to talk out their real-time thoughts during customizing hand and wrist orthotics. A standard VPA procedure was conducted to construct the coding scheme, and depending on the scheme, time spent on major phases and activities were calculated to build the time chart, which is shown on the right of this page. Statistical analysis was conducted to evaluate if the 3 factors are imperative. First, the result showed that inpatient had more stabilized joints than outpatient, which indicated a more complex fabrication process at the inpatient department. This finding indicated that data from in and outpatient should be compared and evaluated separately. Second, the proportional arrangement of time during customization process was identical between outpatient therapists as well as between inpatient therapists. However, there's a significant difference of time spent on major phases between the 2 departments. Third, the results showed that the more experience the therapists had, the more time they spent on customizing an orthosis. It showed that more experienced therapists spent more time evaluating and refining the completed work, which means that some information was missed by less experienced therapists. Working models were created based on the findings to illustrate the ratios of time spent on major phases and activities. An identical pattern can be seen between the 2 outpatient therapists as well as between the 2 inpatient therapists, showing 2 distinct working patterns for in and outpatient departments. Data with high impact can be collected on large scale from specific tasks at the identified place and time, which is reviewed by the working models. For example, distribution of fasteners, angles of stabilizer joints, and hardening time of material, etc. Due to the limited time, I cannot fully explain the method. Please go to our conference and journal papers for more details. Thank you for watching.
Hello, good afternoon. I am Omsri Kumar Edula, co-author along with D211 and Tobias Larsen, presenting our paper on data analysis method supporting cause and effect studies in product service system development. We are from Blekinge Institute of Technology, Sweden. The major learnings from this presentation are how a data analysis method supports cause and effect analysis in design exploration studies through variable based on the structural hierarchy of the evaluated system, and how the proposed method was exemplified in a case study. Introduction. Designing industrial products or services is nowadays normally a group effort and rarely an individual act. With the transition away from product towards providing product service systems, increasing product complexity, and a long prevailing concurrent engineering approach, emphasizes the need for collaborations to cross-functional teams for rapid and reliable evaluation of different options in product development, especially in the early phases. Therefore, it is important to develop collaborative environments that documents decision-making ability in early design. Relating to that, previous research proposed a model-driven environment for collaborative decision-making focused on the early phases of the engineering design, wherein data analysis and visualization become key enablers. The design team generally deals with complicated systems containing multiple subsystems and components. To understand and assess the study system, design exploration studies are conducted. Design variables in these design exploration studies are, however, rarely directly identifiable as a subsystem or a component. Rather, a subset of design variables in an experiment combined with parameters and constants drives the configuration of a particular component or subsystem. This abstracts and slows down knowledge sharing and communication in cross-functional teams. The guiding hypothesis of this paper is that associating data and information with identifiable components and subsystems within the studied system is an efficient way to share information, aiding understanding in a cross-functional team. The paper aims to support the quantification of dependencies between design variables and design attributes on a component or subsystem level in case where more than one design variable drives the configuration of the component or subsystem. Coming to methodology, the figure here shows the proposed data analysis method for the cause and effect analysis, thematically showing its role in the concept evaluation process. The method is designed to work under the assumption that the variables are continuous and linear. The input data is partially regressed to determine the beta coefficients, and the clustering variables are summed up utilizing their respective coefficients. Variables are standardized to analyze them independent of the metric scale. The partial least square regression is a statistical method to find the linear regression model applied to understand the cause and effect relationship between the design hierarchy levels. Well, for results, an existing dataset originating from a design exploration study of road construction equipment was used to illustrate the proposed method. The dataset contains 700 concepts with 7 design variables and 16 functional attributes. These 7 design variables are clustered according to structural hierarchy of the study system, reducing the total number of design variables to 5 at the intermediate level. Out of the 16 functional attributes, net present value relationship with the design variables are shown in here. Here the clustering variables are frame angle and tank volume under front frame, and battery technology and battery capacity under battery. The proposed method with clustering does not affect the significance of the non-clustering variables. If, for example, in this case, the connector length remains same at both the levels, and the motor or bearing does not have any significance at both the levels. This is due to variables being categorical. To fit the intended visualization scheme, the values from the right part of the figure were used as a basis for color coding the CAD representation of the studied system. An example of color-coded CAD model is shown in here with color schema ranging from red to green over yellow. Here red represents a negative effect on the studied attribute, whereas green represents the positive effect. The figure here shows 4 different studied attributes and its associated color coding. Summarizing, the major findings of the paper are a data analysis method for supporting cause and effect studies for multiple design variables, a method of clustering without losing the significance of the non-clustering design variables, providing a means for visualization construct based on color coding the CAD model. Overall, a method to support collaborative design decision making through visualization of derived cause and effect relationships. Thank you.
Good. I hope that you are all able to see the presentations. At least it works for me well. I would like to invite our speakers to now turn on their mics. It would be great if I summarize. I think we had 5 great papers that covers everything from the literature review in the field to the through the actual specification of the data needed, to the reflection, to the generation and evaluation of the concept, through support to the tools, and kind of actually supporting different cause and effect studies in product service systems that we have seen. I think these 5 papers together provide us a lot of opportunity to discuss. I also hope that you are able to read the papers, because, as you know, they have been published many months ago online, and I would like to open discussion. So I invite our audience to ask the questions in a chat channel, or they can also request to share audio and video. We have one spot left for audio and video, and then we can actually allow one by one of the members of the audience to join us on the stage, on a virtual stage, and ask the questions. So please, yeah, do that. Do we have someone from the audience who would like to start? Okay, maybe when they are thinking about the questions, I would like to ask our panelists today, what do you think about what are the most critical, so based on your research, what are the most critical data actually to stimulate this early stage of design, concept development, and in general early stage of the product development? Could you please offer me your viewpoints on that? Who would like to start? Alessandro, maybe you?
What are the most critical? That's a good question. Most critical part is actually to decide what are the data that you need in your specific case, which are very much customizable. I think there's not an issue of actually having the data. It's an issue of having too many data that you might actually not be able to prioritize. And that's an issue that we see quite often, I would say. Which we have access to data. We have actually huge amount of data if we talk with like collecting data from machines, etc. But then when you need to boil that down to actually derive some indication for design, then you need to make this data need to make sense out of those. And often those are not really, the data collection activity itself is not really designed for allow designer to design better, but rather designed for allow service manager or customer service to be aware of what is happening on different machines, for instance. But boiling this down to what actually they're designing something based on this data is quite a huge challenge that I see right now.
Okay. Do we have some other opinions from the panelists on that? Would someone like to add something?
Yeah.
Please be free. Yes, please go.
Okay. So maybe I'll add something. So I think for me, it's like, I quite agree with Alessandro. So I think it's like, for me, the data source. It's like there are too many data nowadays. So we need to decide which data or which data is actually useful for design. So I know like a lot of researchers, they use data from patent. They retrieve data from patent, they analyze them, process them, and use them to stimulate design, stimulate concept development. But I also read some other papers, they criticize this kind of patent data. And they basically say patent data are quite outdated because it basically takes a long time to get something patented. And also they think like the data from patent are quite difficult to understand for designers. So maybe we should think of some data that is quite easy for designers to understand and use them to stimulate like the early stages in the like conceptual design and stuff like that. So that's what I think is like most critical. I think the data source, which data are more useful, and like which type of data we should select. Okay.
Good. Someone else to add something?
I have something. I think I actually not agree that we have, I agree that there's a lot of data both in the companies and other places, but I think that the data we have is not usable at all because it will take way too long to get anything out of it. So if I have a design process and I need to go 100 patterns to be better to get some inputs to my design, I don't have time to do that. So I think the whole idea about using the data, that's actually a bigger problem than it is to have the data. Because it's just take too much time to clean the data to make it usable. So if that takes 80% of the time, I will not do it. So I think there's a big challenge there.
Okay, good. Other panelists, would you like to add something, or maybe we can broad discussion and maybe think about most of the papers in this session dealt with the textual data mainly. Do you think that can be a little bit discuss different types of the data when talking about data-driven design that are more or less useful? So what is your opinion when we compare the textual data versus other formats like visual drawings, etc.? Of course, what are the problems in harvesting them? Maybe comparing it to the textual data. We know that for the textual processing, and it was mentioned here, at the moment we have the tools that are able to do it. We have a lot of machine learning algorithms and tools that can help us to kind of harvest the knowledge out of it and use it. How we actually deal with the other types of the data that are very important in the early stages. Maybe Xinjiang would like to actually tell something about that.
Yeah, sure. Because I'm working on the medical devices.
Yeah.
Basically, now the small wearable devices, especially for ICUs, right? Lots of equipment connect to the body of the patients, and there's tons of sensors that are collecting data all the time. So you don't need to really collect something on purpose, because all the sensors are collecting the data for you. So we have high volume of data every time, every day. So how to collect or how to select that data that's really useful for the patients to improve the function of the device or improve the medical service in the hospital. So the one way, because I communicate with doctors a lot, like the things like the thing they are always worrying is not what kind of data we are going to collect. It's that there are already so much data, so they are worrying how to reduce the volume of data that has been collected. And one way we have been testing is to say to basically evaluate this, if the sensor in this device is really valuable or really necessary. So because there's so many sensors, by reducing the number of sensors, that reduce the number of data volume collected every day a lot. So by cutting down the source of the data collection may be an effective way to select the valuable data by evaluating the necessity of the data source. That may be a one way interesting to explore. Yeah.
Good point. Some other comments on that? Maybe we were discussing not only the differences between the different type of the data, but also there was the mentioning of historical data, isn't it? So Kristoffer, could you reflect on that? Why you think that, what is the difference between historical data and the data so that exists in the systems and importance for decision making, comparing it to the data that are available maybe from other sources at the moment?
I think the strength of historical data is that it's bound in the products we already have in the company. So therefore, it's very close related to probably what we want to do next. So therefore, I see a lot we can learn from the historical data that we should be able to take forward. But you can say if we use sensor inputs for machines and stuff like that, the second we have the measurement, it will also kind of be historical data because it's something that happened in the past. So I think that's the same kind of data that we can use those data to take better decisions. But of course, there's also data outside the company. That could be patents, that could be user surveys, whatever things. And I think those are also very valuable to learn a lot of stuff. But I think it's very different how we can use them. So at least the approach we had to look into the historical data, that is to get a tool that can help us evaluate performance. And you can evaluate performance a lot of different ways, but if we can use historical data, it might be faster and easier to do. So that was kind of the goal with use of historical data. I don't know if that was completely an answer for your questions, but I think it was, yeah.
Yeah. Any other talks on that from the panelists? Okay, then maybe we have a question in the chat from one of our from one of our participants. So Waqas Khalid asked Jihan actually which computational tools were used in your study for creating design ideas, which is nice because it brings us from the data and type of the data to the how to use them, how to formalize the data and what tools to use. So Jihan, if you can.
Okay.
Yeah.
So we have two tools that are used in the paper. So one is the tool to create the knowledge base. So it's called Beeling. So Beeling is actually a knowledge database. So how we created that database is we use text mining and like very simple machine learning to crawl the Elsevier database, to crawl the keywords of each academic paper and to find the relations between the keywords and to build the database. So this provides us a technical database to help us to understand the latest technology or latest knowledge in the field. So that basically gives the designers the basic understanding of the knowledge they don't really know. And for the tool we use to generate ideas is called the Combinator, so which is actually developed a few years ago. So the Combinator is based on a theory called combinational creativity. So combinational creativity means unfamiliar combinations of familiar ideas. So it's basically connecting the things you know together and to make a new combination, a new idea. So in that tool, we created a database ourselves. And so the data we selected are actually from a design website. So it's called Yanko Design. So it involves all kinds of like latest designs in the field, product design, and etc. So we also use like a web crawler. We crawled all the text, and we extracted all the keywords from it and created that database. So, but in that database, the keywords, they don't have any relations. So how the tool works is you like enter a keyword, let's say like a kettle, and then randomly it will pick a keyword from the database and combine it with the tool, combine it with the input, like the kettle, and then it's going to like retrieve some images and produce a combinational image or integrated image and to stimulate designers in idea generation. So that's the tool we use.
Yeah. If I may add to this, I'm wondering, you often have the situation with polysemy of the word, so semantic distance between them, etc. Is this tackled in a tool, or how actually how this is resolved? Because yeah, it may happen with the different outputs, isn't it?
So at the moment, it's like randomly combined. So we also had another paper like published last year, I think, in the ISEC conference. It's about semantic distance in combinational creativity. So what we did is we investigated whether two ideas, if they are far related or closely related, how like the effects, how they will impact the output. And what we found out is that from a like design expert perspective, they think that far related ideas, or they have like far semantic distance, they can produce or lead to ideas that are more creative than the closely related ones.
Okay, good. Then we have another question from the audience. Is Daria Vlah, who is asking, and she's asking, how do you decide which data should collect that would be useful in the stage of design? I think we already tackled it, maybe a little bit in the first questions, but if there is some other or additional thought on exact data that should be collected, that would be helpful. I think we touch it a bit with the critical data in the first question that we had. I don't know if there is anything else that you would like to add, or we should proceed. We have then another question from the Mary Lou. So I'm pinning the questions at the top of the chat so you can see it. So Kristoffer and G, when using data about previous design, how do you avoid repeating the negative design issues of the past? Kristoffer and G, if you can answer.
Yeah, I can start. That's the whole key of using the historical data to see which part performed well and which part does not perform well, so we can avoid repeating the negative products. So I think that's the core of doing it, that we can test our concepts much faster and therefore don't repeat ourselves, to make sure we choose the best.
Good.
Okay, so I'll add something. So for us, like the data we use is from previous data, from previous designs. So basically, we can say it's kind of robust. It has already been used, so it should work fine for nowadays design as well. But what we think is it might lack of kind of creativity or novelty in new designs. So maybe what we are trying to do now is trying to use some like live data, like the data nowadays, especially, nowadays there are a lot of emerging technologies, a lot of new technologies like have been developed nowadays. So maybe we think about like use the crowd knowledge, like knowledge from the, like from Amazon or from like the customer reviews to get some insight from the customers to see how we can use those data to support us in idea generation.
Yeah, and we have the following up the question. Thank you, Mary Lou. So she's asking, in your application, you make use of data set that are based on previous designs. Who is responsible for curating design data? Is design curation needed for each of your application? Maybe we can actually start from Oms. He was not. He was not talking much so far, and then we will continue with others.
I was not talking because I agree with the other panelists here. So coming to the question, yes, in my case, we use the previous data. So in my application, it's complete. The data is based on the application. So the application data was used to visualize so that we improve the design. So in this case, yes, curating data is necessary so that we visualize the impact of the design and then improve the conditions for decision making.
Okay, and others? Of course, Alessandro had the literature review, so maybe he can tell us maybe what was general conclusion from the.
I mean, I'm doing lots of data-driven design on different cases as well. So what I can say for what I see is that we would need to have someone actually curating the data, especially when you talk about using historical data to learn about what went wrong, what went well. But I don't have many experience directly or actually people actually take the role of curating this design data. So I think it's having a responsible for curating data, even for making sure that those data are there and are in the right condition to be used, is a quite relevant step if you want to really move into what we call data-driven design. So being able to take decisions based on actual data that you have. I think it's totally needed to answer the question, and I think it's not clear who is responsible right now. At least in many of in a couple of cases, can't say many, but at least two or three companies we are working with.
Okay.
There's also an issue about sometimes about who is actually owning data. If you talk about bigger systems like network of machines, etc., there are often suppliers of IT solutions and the communication architecture that comes in and offer services. And actually, there's a kind of the discussion about who is actually owning data that are collected, for instance, from machines. Yeah. And data is value in that case. So.
Some additional comments on this question from our panelists? Okay, we were then at some point, I think Jihan mentioned the crowdsourcing and open innovation and this type of the data sources, how this fits, how this integrates into the the process of the company's early stages. What are the needs? Because it is not so easy to just include external data as they are, or use the crowd to provide it. Any maybe ideas or further talks about it from someone from the panel? Not particular. Okay. Then we can move to the next question as well. I think Ji Young was discussing the product customization that I think is very, very important and definitely will be driven by the data. We see that in many services around. More and more services particularly offers that based on individual data. Do you see this, how this will impact maybe the engineering design process as well? I have some experience from other industries, like the services that are related to the health, for example, where all of them are tailored really particularly to every single individuals, even based on their DNA traits, for example. So this is totally another level of the data that we are collecting about every single user in order to tailor the service. Do you have any maybe comments on that? So how far we can go with that in a, let's say, more classical product development or development of the product service systems?
I think it's quite good if we really can use the individual data. But I think the problem might be how do we collect the individual data and how do we use them? It's quite difficult to collect individual data. That's what my opinion. I think that might be the biggest challenge in this kind of using individual data. But I think especially for healthcare products, I think Xingyang has a lot of experience in that. I think in healthcare product, I think individual data is much more useful than the other data we have got. It's healthcare is also always about customized to the person who is using that product. So I think it's more about how do we collect the data and what kind of data the users could provide. And the users might not really know what data they should provide. So we need to think about a way to collect the data and to collect the data which are actually quite useful for the product.
Comments from others?
So basically, yeah. So product customization, especially for patients, is quite different from normal customization devices for health data, because not like the shoes or some gloves or helmet that you can just the thing about customization is fitting or not, but for patient that's related to the treatment, to how progress the condition will be. So that is more or more significant for this kind of specific group, and rather considering not only considering the comfortable or the fit of the devices. So we taking the condition, the treatment, or the medicine effects also in the model or in the system you created to make the product. So in my case, for example, we design a customized soft sensor skin for patients with head injuries, like the bone fractures, and for the customized orthoses to help them stabilize the limb. So we have the soft sensor skin customized for each of the patient that can attach to the skin and measure the contact pressure under the orthoses to monitor the excessive contact pressure and to remind the orthoses to get rid of the excessive contact and help them improve the fit. So at the beginning, we have a sensor area, like 20 by 20. There's a lot of sensor units on the hand. So, that is for all kinds of patients. And then we collected a high volume of data every day. Then we're using the data to recognize that the key point, like the critical area on the injured hand. So which data is really useful and which data is not. And we reduce unit and reduce to 13, then 12, then eventually we have only 5 sensor units on the hand that can capture the essential data. So that is enough diagnosis and treatment. So I totally agree with G just said that the patient don't know, if you ask patient which area on your hand is uncomfortable, they won't tell you because they have the pain all the time. The pain affecting the perception of the discomfort or the tightness of the orthosis. So the only way is that we have a system that created for them, that collecting data and using algorithm to simplify the system, that eventually you have effective data, but in a small volume that you can practically analyze this. So that's maybe a special aspect from product customization for patients.
Okay.
Yeah.
Thank you. Some other thoughts on that? We have a few more minutes left, so I would like to encourage again our audience if someone have additional question or last question. Otherwise,
can I pose a question?
Yes, please. Yes, absolutely. Oh, that's fantastic.
A question to Kristoffer, and I think it's really related with Omse's work as well, is about when you have this product decomposition, as I call it, with different tables related to data, how do you deal with the reliability of those data in early design? Sometimes, very often in early design, you are not really sure if that data that you put into the table is a 0.5, a 0.9, a 5. Do you have any method to deal with uncertainty related to this data and the approach you have presented?
Yeah, you can say we use historical data, so it's recorded a long time ago, you can say. And the way we have dealt with it, if we have first of all cleaned it, so the outliers and stuff like that, we have basically just sat down with experts for the company and say, do we have the same understanding of this? Can we rely on the data? And then, of course, it's not perfect and definitely not 100% perfect, but it's a much better starting point than scratch. So I think that was at least the way we deal with that.
In my case, it's more of a configuration data. So we kind of used to some other signal processing techniques to remove the noise and uncertainties like J-scores or linear regression models and stuff.
Okay, thank you.
Thank you.
Good. Okay, then to conclude, I would just like to ask each of you to tell us in short what are the next steps for your research. So we can maybe start by the order that the presentations were given. So Alessandro, then Kristoffer, etc. So what are the next steps in your research, in your specific research that you presented?
And the next step in this research for me is to actually narrowing this down to creating digital twins for construction machines. So we're narrowing it down into construction equipment and road construction. We're actually collecting data live from machines now, and trying to define what type of data and in which form should be useful to actually redesign better machines.
That's interesting. We have similar projects with the tooling for sheet metal design, actually. So with the company that we also are collecting some data in order to do the same. So we should talk. Definitely. Okay, Kristoffer.
Yes, I think the next step is two things. One is to you can say investigate more of what you can use the data. Because I think we have a quite good structure of the data, so we just need to map out the possibilities we have with the data. And the other part is we would like to test it out more places. So now we have 2 cases, so we would like to have the next case to try to see if we can do that with a new company and new data and stuff like that.
Okay, with the goal to lead to generalization of the approach, or just to collect more?
I think to show that how valid this data we already have stored in the company is, and how we can use it to take better decisions both in development process, but also in running our company, so in our maintenance process and our service product process as well. So that's the overall goal.
Okay, good. Thank you. Jeep?
Okay, so for me, so in this current paper, we just proposed an approach. So we suggested what tool we can use. So it's not have been finalized. So we're trying to finalize the tool we should use, and maybe develop some new tools and integrate everything together into a whole tool. And then we trying to run a real case study to find out whether our data-driven approach works or not.
Okay, thank you. And then Jian?
Right, so we have found that the method we established with the verbal product analysis, we found that it is a very useful tool to extract the critical data that's related to patients and doctors in hospitals. So for the next step, we'd like to explore this method further, to go to different types of services in hospitals, and how that method can be used to identify the critical data, and how that critical data can be actually used to improve the services or products in hospitals. So yeah, that's basically the bigger picture of the further study.
Good, thank you. And finally, Omshi.
Yeah. So this method, in our paper, the method mainly focuses on few assumptions, like the variable should be of continuous and linear. So the future work for our project is to remove these assumptions and work on the data, which is irrespective of linearity, and also considering the interaction effects and just focusing more on the other methods and comparing with the present method.
Okay, good. Thank you very much. Actually, it was really nice and live discussion. Thank you all participants to join us, to asking the questions. And I would like to invite you, and also our panelists who did a great job today. Thank you very much for a collaboration. I would like to invite you all to the stage where the keynote of Professor Maher, who was actually active in this session, will start in 15 minutes. And I wish you all a successful conference. Yeah. Thank you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye-bye.
Bye.